Hi everyone, welcome to Mathly. In our last video, we explored simple linear regression, a fundamental technique that models the relationship between one dependent variable and one independent variable. If you haven't seen it yet, make sure to check it out first in order to build a strong foundation for today's topic. In this video, we're taking it a step further by diving into multiple linear regression, a technique used to model relationships between one dependent variable and multiple independent variables. Multiple linear regression expands the simplicity of its counterpart by incorporating more features to make more robust predictions. This makes it incredibly useful for tackling complex real-world problems where outcomes depend on multiple factors. We will break down the concept, how it works, and how to visualize it using the Orange data mining software. By the end of this video, you will understand how multiple linear regression works and how to apply it effectively. Let's dive in. Linear regression is a statistical method used to model the relationship between a dependent variable, the one you want to predict, and one or more independent variables, the inputs or features. While simple linear regression focuses on one independent variable, multiple linear regression extends the concept by involving multiple independent variables. Let's break it down with an example. Imagine you're running a cafe and want to predict daily revenue. But this time, instead of relying on just the number of customers, you consider additional factors such as the time of year, weather conditions, and seasonal trends. Multiple linear regression helps you establish a mathematical relationship between these variables using the following formula. Y equals b0 plus b1x1 plus b2x2 all the way to bn xn. Here's what each term means. Y, the predicted outcome, like your daily revenue. B0, the bias term or intercept, representing the predicted value of y when all independent variables are 0. B1, B2, all the way to Bn. The coefficients, which indicate the contribution of each independent variable to the prediction. X1, X2, all the way to Xn, the independent variables such as the number of customers, weather, and seasonal trends. Multiple linear regression works by finding the best fitting plane or hyperplane instead of a line that minimizes the differences or residuals between the actual and predicted values. This method allows us to account for the combined effect of several factors, making it highly effective for solving complex, real-world prediction problems. In essence, multiple linear regression gives us a more detailed and accurate understanding of how multiple factors influence an outcome, making it a vital tool for decision-making and forecasting. Let's break down how multiple linear regression works into three simple steps. Step 1. Gather data. Imagine you're working in real estate trying to predict the price of a house in $1 million based on several features. House size in square feet. Larger homes generally have higher prices. Yard size in square feet. A bigger yard often adds value to a property. Number of bedrooms. More bedrooms can increase the price. Proximity to schools. Houses closer to good schools may attract higher prices. For simplicity, let's focus on house size and yard size as the two main features. You would collect data about recent sales, including these features and the sale price, to form your dataset. The more diverse and accurate your dataset, the better the predictions will be. Step 2. Fit the plane or hyperplane. In simple linear regression, the relationship between one feature and the target variable is represented by a straight line on a 2D plane. However, in multiple linear regression with multiple features, the relationship becomes more complex. As you can see in this example, with two features, we now fit a plane instead of a line. Each point represents a combination of values for the features, example yard size and house size, and the corresponding house price. The plane minimizes the error just like the line in simple linear regression. When additional features such as the number of bedrooms or proximity to school are included, The model finds the best fitting hyperplane in higher dimensional space. While we can't visualize beyond 3 dimensions, the principle is the same. The model establishes the relationship between all independent variables and the dependent variable. Once the hyperplane is established, you can use it to make predictions. For example, if you know the house size and yard size of a property, the model will estimate its price based on the relationship established in the data. The ability to include multiple factors makes multiple linear regression much more versatile than simple linear regression. It's especially useful when dealing with complex problems like real estate planning, where many variables interact to influence the outcome. While the concept of fitting and prediction remain similar to simple linear regression, the additional features in multiple linear regression give you a deeper understanding of how various factors impact your outcome. By leveraging this, you can make data-driven decisions with confidence. Now, let's move into Orange software. In this video, I've kept the Orange software setup the same as the one we used in the Simple Linear Regression video to ensure better understanding. The only difference this time is that we are using the food delivery time prediction dataset from Kaggle. So I've imported the food delivery time prediction dataset from my local machine. After loading the dataset, I have used the data table widget to read the data. Here you can see the training data which contain distance, the distance to the delivery location in kilometers. Weather describes the weather conditions. Traffic level indicates traffic information. And there are a few other columns such as the time of day, vehicle type, and so on. And the target column here is delivery time, which is indicated in minutes, and it is what we aim to predict. Let's look at one row as an example. Order ID is 522, and there is a 7.93 kilometer distance. The weather at the moment is windy, traffic level is low, the time of the day is afternoon, and like that, there are these aspects, and then the delivery time for the order is 43 minutes. Like that, the dataset includes 1000 rows in the training data, providing plenty of information for building and training the model. Next, I have used the Select Columns widget to organize the data for our prediction task. For the target, I have selected the column we want to predict, which is delivery time. In the Meta section, I have added Order ID. Meta columns represent additional information that is not used for prediction. In this case, the order ID helps identify individual orders but does not influence the prediction task. All other columns such as distance, weather, traffic level, and other columns are included in the features section as they are used for making predictions. This step ensures that we are focusing on the most relevant data for building our predictive model while keeping additional information for reference. With the features defined, I have added the linear regression widget. This widget trains a regression model to predict delivery time by learning the relationship between the features that were given. So the model uses the training data to establish these patterns. For instance, if the traffic is high and the distance is long, the model might predict a longer delivery time. Conversely, if the preparation time is short and the courier is experienced, the predicted delivery time might be shorter. So multiple linear regression provides a straightforward yet effective way to understand how various factors influence delivery time. And then I have added a new file widget called testing data, where I have included 10 rows with the same feature columns as the training data. This testing dataset will help us evaluate how the model predicts delivery times based on the input features. Now let's see how the model performs on this new data. Next, I have added the predictions widget to evaluate how the model performs with the testing data. For example, in the first row, the order ID is 1000, representing this specific order. The delivery distance is 15.32 kilometers and the weather condition is cloudy with a high traffic level, indicating challenging delivery conditions. The delivery took place in the morning using a scooter with a preparation time of 25 minutes. The courier has 8 years of experience, which also plays a role in delivery efficiency. Based on these inputs, the model predicted a delivery time of 84 minutes, highlighting how various factors such as distance, weather, traffic, and courier experience contribute to the prediction. This shows how the model uses the features from the training data to predict the delivery time. By looking at the results, we can see how different factors affect delivery time and how well the model performs. With this, the workflow is complete, showing how orange data mining helps build and test predictive models easily. In real-world applications, multiple linear regression is a powerful tool because it allows us to model outcomes influenced by multiple factors. Unlike simple linear regression, which examines the relationship between just two variables, multiple linear regression takes into account several independent variables working together to predict a dependent variable. Let's explore a few examples where multiple linear regression is useful. Healthcare. Medical professionals use multiple linear regression to predict patient recovery time after surgery. Variables such as age, pre-existing conditions, length of surgery, and post-operative care are all analyzed together to estimate the recovery duration. This helps in tailoring patient care plans effectively. Education. Educators and administrators apply multiple linear regression to predict student performance in exams. Factors like hours of study, attendance, prior academic scores, and extracurricular involvement are evaluated to understand what impacts performance the most and to devise better teaching strategies. Real estate. In the real estate industry, multiple linear regression is commonly used to predict property prices. Inputs such as location, square footage, number of bedrooms, age of the property, and proximity to amenities are considered to estimate market value accurately, helping buyers and sellers to make informed decisions. By leveraging data from multiple variables, multiple linear regression provides insights into intricate patterns and empowers data-driven solutions in diverse domains. And that's multiple linear regression. In this video, we explored the fundamentals, how it works with multiple variables, and its real-world applications. I hope this tutorial helped you understand how this powerful technique can be used to analyze complex relationships in data. If you found this video helpful, don't forget to like, share, and subscribe to Mathemly for more data science tutorials. Comment below with what you would like to learn next. Thank you for watching and see you next time.